If the temperature of the human body increases or decreases beyond the ideal range, it might lead to unpleasant effects that affect your overall health and performance. For example, if you're running at temperature, you may experience sweating, headaches, weakness, and shivering that hamper body functions. And the same goes for when you're cold, but instead of sweating, the body shivers in an attempt to increase temperature back up to the normal range. Unwanted effects of temperature fluctuations are not limited to just the functions of the human body. The performance of an electric vehicle is also put to test when the temperature of the battery pack, electric motor, and motor controller go beyond their normal operating range. Similar to the way the human body monitors and manages temperature, EVs are equipped with a thermal management system, or TMS, that is designed to monitor and control the temperature of the battery, motor, and motor controller. When electricity flows through batteries during charge and discharge, it generates heat because of electrical losses. If this heat is not managed and eliminated appropriately, it may limit the performance of the EV or pose a safety hazard to passengers inside it. And just like how our bodies need an ideal temperature range to feel and function well, batteries also have a range at which they demonstrate optimal performance. In fact, if their temperature goes above or beyond this range, it may lead to cell degradation. The battery pack may also be prone to thermal runaway, where the amount of heat developed inside the battery crosses the amount of heat released to the surroundings. Over time, this heat accumulation can damage the battery. When the temperature of the battery is managed, the overall health of the battery can be preserved. This in turn helps the EV achieve maximum range and performance. While thermal management is essential for the battery pack, the TMS also ensures that the temperature of the electric motor and motor controller are maintained within the optimal range. If the temperature of these parts rise, they are prone to catching on fire, which stops the working of the system. And if the motor in an electric vehicle stops working, the EV ceases to move. In order to prevent issues in the electric vehicle because of overheating, the TMS cools the parts using one of three methods: liquid coolants, air cooling, or cooling fins. Here's a quick look at each one. Circulating a liquid glycol coolant through the internal circuitry is the most dominant method of cooling used in EVs. Many car manufacturers like Tesla, BMW, Chevrolet, Audi, and Jaguar employ this method. The entire cooling loop is connected in series. It starts off cooling the battery pack, moves on to the motor, and then the electronic systems. When going through the battery pack, glycol from the reservoir passes through the tube surrounding each of the cells. The tube snakes between the cells to maximize the amount of contact between them. As it moves along the cells, it absorbs the heat generated by them and dissipates it to the air through the radiator. For cooling the motor and motor controller, a coolant-to-oil heat exchanger passes oil through the grooves in the stator of the motor. This system also absorbs the heat and releases it via a radiator into the air. Coolants like glycol are used for their low freezing points, high thermal conductivity, and high heat capacity. Used to a lesser extent is the air cooling method, which involves circulating air over the top of the parts. It will absorb the heat, move it away from them, and into the air. However, this is not a preferred method as air has poor heat conductivity. Cooling fins are also used to cool the system as they increase the surface area needed for heat transfer to take place. When the heat gets transferred to the cooling fins from the battery pack through conduction, it is transferred to the air via convection. But as they add more weight to the EV, it's not a preferred method of cooling. But thermal management in an EV goes beyond just cooling the battery pack, as it also involves heating the battery pack in low temperature conditions. This is because battery capacity is greatly reduced under low temperature effects. And now you know that temperature control is just as important in electric vehicles as it is to the human body.